I hope you can hear me. We talked about slope relationships on the coordinate plane. We talked a little bit about ratios to clear up some understanding. So if you're having trouble with that, let me know. We did this as a class and then you turned it in. So it's just for a completion grade. So feel free to turn it in if you haven't. So what we do, slope is just rise over run, right? Rise, man, I'm running out of room here. Rise over run. How much we increase or decrease vertically versus how much we move to the right. And the way we can do that with just a graph is we can look at these 2 points, and we can draw what we call a slope triangle. So from these 2 points, we can see this is how much it goes down. It goes down by 3. So we're going to say it goes down, when it's saying what is the slope of line A. And it decreases by 3, we're going to say, oh, this is -3. Since we're always going to the right, we want to make sure we properly label our increase or decrease in height appropriately. That is one of the most common things to mistake. And how much does this go to the right? 1, 2, 3, 4, 5, 6. So we'd say our slope is -3 over 6, which is simplified to -1/2. Now we're asked the slope of line B. Let me move down a little bit. Let's see. We can do it this way or this way, like over or under. It still works. Here we go to the right 6, but we go down -3. In this case, we have to be careful because now we're choosing this -3 first instead of the 6. We want to make sure which numbers we're choosing first. It decreases vertically by 3, so we're saying -3, and it increases horizontally, laterally by 6. So this happens to have the same slope. And these lines are, when they have the same slope and they aren't on top of each other, like smushing together, they aren't equivalent lines, we call them parallel. So what do we know about parallel slopes? They are equal. Let's take a look at the next set of lines. What is the slope of line C? This is line C right here. We got these 2 points here. Or we could actually use any pair of these 3 points will get you the answer. Let's use the farthest 2 away. We're gonna draw our triangle here. So this goes down 2, and it goes 1, 2, 3, 4, 5, 6 to the right. So the rise is -2, the run is 6. So this slope simplifies to -1/3. Now we're asked about line D. Let's use this point that I already have in red and this point up here. So we have, let's see, we're going up, so this thing's going to be positive, right? Let's see. Oh, man, I wish I can draw straighter lines. 1, 2, 3, 4, 5, 6 up and 2 to the right. So our rise is 6, our run is 2. So this simplifies to a slope of 3. What we can see from, when we're asked what is the relationship between these 2 lines? Well, they create a right angle. They are perpendicular. The term for perpendicular is that, right? But I'll just write perpendicular. And I'm gonna express a relationship in slope. If we think of this as 3 over 1, the relationships are, well, we have 3 over 1 versus -1 over 3. So we see a connection, 3, 3, 1, 1, but there's a negative there. So it is a reciprocal, meaning we reverse the numerator and the denominator, and it's also opposite, meaning we make it negative if it's positive, we make it positive if it's negative. So we call that opposite reciprocal. I hope I spelled that right. Okay. Last one. We are going to find the slope of these two lines. Line E. We start right here. We go right there. Let's see. Drawing slope triangles makes it a lot easier. 1, 2, 3, 4. Dang. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it goes up 5 and over 5. 5 over 5, that has a slope of 1. Let's take a look at this guy, this line F. We can't really draw a triangle because it doesn't go up at all. This thing goes over, and I remember from class, it goes over 11 spaces. So if its rise is 0 and its run is 11, well, that solves to a slope of 0. It's possible to have a slope of 0 where 0 is on the numerator. If you have something like 11 over 0, that would be an undefined slope. That would be a vertical line, which we can't have in a y equals equation. So we can't have that. So with the relationship between these two lines, they are neither perpendicular nor parallel. So the other term for that is intersecting. How are their slopes related? Well, they're just different slopes. There's no relationship. So it's different than what we say over here. If it's not the opposite reciprocal and it's not equal slope, then they are just intersecting. They intersect at a different angle. That's all they're saying. So I hope this helped. See you all Monday.